Welcome to this special episode of the Geotechnical Engineering Podcast. In today's episode, I'll be talking to Pedram MolkAra, who's the Geotechnical Lead for Canadian Buildings and Infrastructure, Mining, and Environmental Services at Jacobs. We'll be talking about the current state of geotechnical engineering, including the challenges faced by small firms, the risks and liabilities involved with geotechnical engineering as a whole, and the essential skills for project management for geotechnical engineers. I'm your host, Jared Green, and I'm excited to be bringing you another episode of the Geotechnical Engineering Podcast. But before we get started, here's a quick word for our sponsor for today's episode, that being Keller. Pedram, welcome to the show. How are you doing?
Hi, Jared. I'm doing very well. Nice to meet you.
Likewise. I was so excited when I saw you were going to be on the podcast. I was like, oh, this is going to be great. It's going to be great.
Thank you. Actually, I was a little bit nervous because this is the first time I'm doing something. And first, when they approached me, I wasn't sure if they did it right or if I'm the right person. But anyway, after I did a little bit of digging, I'm excited, and let's see what happens.
Yeah. Excellent, exactly. Let's see what happens. It's good. It's good to try new things, and everybody, Absolutely. Everybody that's done something, they had to do it to start, right? So this is good. This is good. So it'd be great if you could tell us a little bit more about yourself and how is it that you got into geological engineering?
Yeah, that's a good question. You're gonna have an interesting answer. So originally, I'm from Iran. I was born in Iran, and back home, when you're growing up as a kid, your parents have two dream jobs for you lined up. You're either going to be a doctor or you have to be an engineer, one of these two. So, I know as kids, everybody says, oh, I started collecting rocks when I was 5, then I did this and that. But for me, first, I wanted to be a doctor, honestly. So in high school, we had a choice of selecting between, going into engineering or into medicine, and I made the wrong choice of thinking that I'm going to go be a doctor. But then after a few years, I realized that that's not the path, and but it was too late. I was stuck with that. So we have a national exam in Iran after finishing high school, and that's where they determine your path in terms of what university you're going to, what major you have to take. And I ended up getting into a very good university in Iran called Shiraz University to study geology. And I was excited about it. Why? Because one of my high school teachers, he was the first one who kind of introduced me and to the basically the possibilities that lie in front of that major, which is geology. So I went in and I started that. But within the first, I would say, first year, I realized that maybe even geology is not the passion that I have, but I was more of a numbers person. And it was the second year that I was given an option in my school to get into hydrogeology, to pick courses which are dealing more with formulas and numbers. So I did that, but I didn't know by doing that, I'm getting myself into geological engineering. So the courses that I took, many years later, I realized when I came to Canada that they were in line with the geological engineering program. So I did that degree, came to Canada as an immigrant back in 1996, and I wanted to go to grad school, and geological engineering was basically the major that I wanted to pursue and continue. So I ended up doing one master's degree in that, and then followed by a second one in civil engineering, just to basically complete the loop and kind of satisfy my thirst. I'm still not satisfied, and as you know, Jared, it's the learning should never end. Like, it should always continue. We're always learning. And I'm glad I did that. Maybe one day I'll go back to school again, but yeah, that's basically the path that I took to become a geological engineer.
Oh, that's great. I guess the shortest distance between 2 points is a straight line. Doesn't sound like that was a straight line, but you got there, right?
Yeah.
Do all these kind of things. So no, it's great. Well, as somebody that's got, over 28 years of experience in the field, what kind of changes have you seen in the current university systems as it relates to training young engineers in geotechnical engineering or even geological engineering? Are you seeing any different trends or changes?
That's a good question. And for me, because I was back at university a couple of times, maybe I can provide a better answer. I think universities need to, like, especially in geological engineering field, when it comes down to geotechnical engineering, they need to, there's room for improvement. They need to adopt better. And why is that? Because it seems the industry is changing. The way the companies are operating, they're changing. I don't see in many companies that they're doing the investment that they should into their young engineers, into their junior engineers, and that's very important. Why? Because I see a gap. Like, as a geological engineer, as a geotechnical engineer, when we start our career, we shouldn't be starting it right behind the desk.
Correct.
It starts out in the field. That's where we learn. That's where the basics are. That's where we build the foundation of a successful geological / geotechnical engineer out in the field. Now, when I say companies and the industry is changing, I see a lot of companies migrating towards the kind of boutique type of geotechnical engineering, geological engineering, using a lot of software to modeling, analysis work, things like that. But where does the information for that come from? From the field, from a good site investigation. And so if the industry is migrating more towards high tech, and the schools are investing more in their students to learn the sophisticated software, where are the future geological engineers going to learn about the fundamentals and basics of site investigation work? Because I don't think that's being properly taught in the school. And I know they have a challenge in doing that because it's expensive.
Yeah.
It's expensive to get a drill rig and have a bunch of students log a borehole, for example. But that's the type of investment I think that the schools need to do. maybe with some collaboration with big companies, with the industry, to along the advanced courses that they're teaching, to also teach the fundamentals or put more stress on the fundamentals of geological engineering. So when we hire a graduate from university, they know how to basically to tell the difference between a silty clay and a clayey silt, right? Or they're familiar with various type in situ testing, that when we ask them about needle conveying, they know what needle convey is, how to do it, and how it operates. So there is that gap. And what I'm worried about is that if there is not proper investment in the education through university or investment from the companies who are hiring these young engineers, after 4 or 5 years, which is that window of opportunity at the beginning of their career, for them to learn these basics, and they move up to higher levels, they become an intermediate engineer and a senior engineer, and they don't have the grasp on the fundamentals. What information are they really feeding into the sophisticated programs to come up with the designs?
Wow.
We don't want it to be a garbage in, garbage out, right?
Correct.
But
correct.
when they're looking at a borehole log, do they have the depth and knowledge to look at the log and say, I don't agree with this characterization. I think the person who logged this made a mistake in terms of the choice they had to pick on the institute test, or if they did the test wrong. If the shear vein results that they're seeing on the log, it doesn't make sense, and they just don't take that and feed it into the program because it was done wrong. So that's the part that I see room for improvement for our education system, for our university, which, I don't think it's happening.
Well, I think you made a really good point there that, collaboration is a good way to address that. So whether it's, field trips or job shadow or internships, or, somebody's doing a thesis, make sure that you have folks in practice that are aligning with what's happening at university. And I think you really make a good point of those first few years of when you're starting out, you really should be starting out in the field. You got to get that field experience before you're doing the sophisticated analysis. But really good points there. Really, really good points there. And what do you think? So you're at a very large firm, and then there are smaller geotech firms, and sometimes people say smaller firms, have a hard time competing with larger firms, and that's debatable, right? Because I think they bid on different types of projects. But how could a firm set themselves apart in order to ensure success in this industry?
A very good question, good follow-on question to what we just discussed. By investing in the fundamentals.
There you go.
By training the young engineers the way they have to be trained. I had the opportunity in my career myself, in the early years, to be part of a very reputable geotechnical engineering firm called Golder, right? And I always speak highly of the mentality that they had in terms of mentorship and teaching the young engineers to make sure they're ready for future. Golder, when you go back to the history, it started with 2 or 3 engineers. And I had the honor of working with employee number 3 in Golder. as one of my mentors. And
Wow.
we know Boulder doesn't exist anymore. Rest in peace, Don Welsh. He was very bright, and I learned a lot from him, along with a lot of other mentors that I've had through my career. But the passion that I got from him in terms of mentorship and teaching young engineers, it was great. I learned a lot. Now, going back to your question, what I see is, bigger firms, they start tackling mega projects, right? The opportunity for smaller firms is not to cut corners, to invest in their staff, because they will be giving back to them. I go back to Boulder model, because that model build a company based on employee ownership. So employees, they felt part of the company, they felt part of the program, and the whole attitude for them kind of, I guess, it changed when they're working for their own company, which was great. But we all know there is a limitation to that type of company as well. And based on what I'm seeing, what I've seen in the past 28 years of my experience, is that there is a limit of growth when it comes down to employee-owned companies. I don't see them getting bigger than 15 to 20,000. There are only a handful who make it to that level. It's hard for them to grow. But again, investment, to answer the question, investment in the young engineers that they hire, not to cut corners, and providing the client with the solution that the client needs. So making it about money for them is not going to build a very good future for them. Because when they do those investments in their work, they will end up with a quality product, which the client will appreciate. Clients will go back, repeat clients will go back to the companies for the quality that they get. If I'm doing a design, a foundation design for you, you will come back to me if the design is sound. But then you won't come back if I have mistakes in my design, right? So I guess there's a lot of things, but maybe I can just sum it in that.
Okay. Yeah, that makes a lot of sense. That makes a lot of sense. And you kind of hit on this a little bit, but what would you say are the biggest risks and liabilities that geotechs have to consider in their work?
It goes back to the basics again. A lot of construction debates, change notices that I see in the industry, or construction claims that I see in the industry are coming back is because the site characterization wasn't done right. It's not because the design wasn't done right. It's because somebody missed an organic layer. It's because somebody didn't characterize the soil the way it should have been. It's because somebody, when they were doing their slug testing, their hydraulic conductivity testing, they didn't pay enough attention to do it right, and the dewatering rates that they got are lower than what it should be, and they end up having to pump a lot of water or do so many other steps because of the lack of information. lack of enough boreholes, for example. It's so easy at the start of the project for somebody to look at a proposed borehole location plan and come back and say, oh, this is too costly. Why are you proposing 10 boreholes? Only go and do 5 boreholes. That's the easiest thing they can do. But what they don't realize is that every single structure requires its own basically approach when it comes down to site characterization, how close the borehole need to be, right? I had a project up north. I had to fight with a client over one of the borehole locations, and it turned out that once we completed the site investigation, that information was so crucial in the design because we hit for example, an organic layer. We were designing a cover for a facility, a kind of tailings cover for a tailings facility. It changed the whole ballgame in terms of how the cover is going to behave once it's placed over that soft organic material, right? So if we had not done that, we wouldn't have known. So it's very important that you stay true to the core and you're able to basically reduce the risk which is associated with the site characterization.
Got it. And keeping with that, start talking about projects and size and scale of projects. I know you've managed projects up to $100 million, and you worked on several multi-billion-dollar projects. So how do you manage high-stake projects like that? And what are some of the skills that are essential for success in project management and geotechnical engineering?
Right. The short answer is being organized. And being organized, it goes to many different directions. Having a very clear scope of work at the beginning, which you can come to an agreement with the client, and then so you have a roadmap on how you're executing the project, and you follow that roadmap. And as you go along and you make discoveries through the project, you're able to go back to the client and address them as sometimes as new scope of work, right? Proper archiving, proper documentation in the project is also super important. It's not just one skill. It takes a whole basically village to be able to run a big program like that. But once everything is organized and is able to basically function like a Swiss watch, as we say, then you're able to deliver. But there's always challenges when you're dealing with large programs like that, and you have to be ready. You have to be able to have a vision to be able to see or predict the unexpected before it comes and hits you. Right? The risk mitigation. How are you going to identify the upcoming risks? So once they're identified, and if they happen, then you have a plan before they showed up. So then you're ready to deal with them. But if you haven't done all those steps, it's going to be difficult because you're going to be caught by surprise, and that communication with the client is not going to be easy and nice.
Okay. Switch gears a little bit. I understand you've been involved in rehabilitation and review of over 50 earth dams, and you carried out numerous dam safety inspections. Can you tell us a little bit more about your experience in this area and also the importance of dam safety inspections?
Right. One thing that everybody needs to know is all dams will leak. So there is, and although we design dams as permanent structures, but they're not, if we don't take care of them within that service life that we define for them, they're going to go through changes that we call in geotechnical engineering deformation. Deformation will happen, right? So to begin with, the dam is going through that deformation. Dams are not impermeable, they're permeable. They are going to leak. So how are we going to deal with this? On top of all this, we have the natural elements working on the dam. It can be as simple as just vegetation and growth of trees and shrubs and grass, down to erosion, caused by precipitation and runoff. So all these elements are working to basically to break the dam, to destruct the dam. Now, if we construct it, even if everything is right, these are going to do their job and basically bring down the dam. If we don't do those routine safety inspections, or if we don't do our routine dam safety reviews to monitor the behavior of the structure and how elements are impacting it, then we're putting ourselves and the client on a very big risk, which is basically dam failure, right? So, and the recent dam failures that we see in the news, and there's been some devastating ones down south, especially in Brazil, in the past 5-10 years, that we know, sometimes it goes back to operation and maintenance. Is operation and maintenance being done right? Are they maintaining the right water level behind the dam? Do we have enough freeboard? Are the spillways being taken care of? So there's so many items that have to be taken care of and monitored for the dam to do its job, to function as a dam. And we can't just leave it by itself and assume that, okay, we built a dam, it's going to function, it's going to hold back this basically tailings or water or whatever it has to do, which may not be the case. Now, in addition to all these, we're going through global warming right now, which, we know it's been happening over the past so many years, and which is bringing the other element of risk to our design, and monitoring, the importance of monitoring that we have to have in place to make sure that the dam's structure is not impacted, because many of these dams were built before these extreme conditions that we are facing right now in terms of global warming, right? The high precipitations and the floods that we're seeing, those dams were not designed for this. At the same time, also, there's, when you look at the mining side, the tailings dam, as you know, we have the different practices or styles of constructing dams. For example, the upstream method, right? Which barely nobody constructs a dam like that anymore because of the risks associated. But there's so many of them that exist right now.
Yeah.
So how are we protecting those dams? How are we protecting the public who lives downstream of those dams or the environment? So that's why such routine inspections and reviews are very important to be followed, and it should be taken very seriously.
Makes a lot of sense. Thank you so much for that. And I'd say you're the founder of the Canadian Geotech group at Jacobs. Tell us a little bit more about how you're doing that and how you're providing quality and consistency across all the geotechnical projects. Like how are you keeping up with all that?
Right. Well, I'm blessed to have a very good team. Mm-hmm. But before that, I've been with Jacobs for about 10 years. and it's been exciting, an exciting journey, and something that when I look back, I look back at my decision to join. Back then, it was called CH2M Hill, a great decision. At that time, before joining CH2M Hill, I was with SNC Lavalin, working on mega projects, like multi-billion-dollar projects. But the opportunity came at CH2M Hill because they didn't have a geotechnical discipline, and they said, okay, we want to build this team. How can you help? How can you help? And basically, I was excited just by the task that I'm going to have the opportunity to build a team, a group of geotechnical engineers. And I said yes. It wasn't easy. It was challenging, but the reward is awesome. It was challenging because basically you have to establish a whole new discipline within an existing ship that's moving, right? So, and some of the elements of the existing ship are not used to the new discipline, right? They're used to a different system, different way of operation. So you have to be able to build trust with them. You have to be able to show that you can do the job, and basically gain their trust, and then build up on the projects that you're doing. And again, I mentioned at the beginning, having the right team members is a very, very important part of it. Team members that they feel ownership also. And basically we all work as a team, not as individuals, to be able to be successful. And it's again, as I mentioned, it's been an awesome journey, and I'm proud of what we have been able to establish as the Canadian geotechnical team at Geotech.
That's great. That's great. Well, before we take our break, I would like to hear a little bit more. I know that outside of your professional work, you run a basketball league, and you've been involved in triathlons over the last 7 years. If you talk a little bit more about how these activities help you to maintain work-life balance. I know that's something that's really important to the folks that are listening and watching.
Right. Well, as human beings, we all need something that we can as a hobby, or to basically a change of course, right? Since I was a kid, I was in sports, so being able to be involved in these activities, it gives me that basically that opportunity to stay healthy, to stay fit, recharge my batteries basically, and have more fun. It's not that work is not fun, but we need to have different type of fun in our life. In terms of organizations, they also help me with organization skills as well. For example, basketball is all about team building, right? Building trust, learning to be a team player as well.
Yeah.
Sure. When can you take control, and when you have to give control, right?
Yeah.
When you take the ball, when you pass the ball,
when
are those right moments? So there's so many things that I can take from basketball to my work model when it comes down to the offense, to the defense, right? How you cover for each other. The floating defense system.
Yeah.
Not to leave a player alone, so he's ready to shoot the 3 ball on you, right? So
Yeah,
Just work is just like that.
it is.
It's not any different. So you can take that basketball model of game, bring it to work, and just fully follow it. When it comes down to triathlon, there's three sports, and there's so many things that you have to organize in your head and be ready for. To gauge your energy level so you can finish the course.
Yeah.
And you don't end up with a DNF category, did not finish category, right? I always tell my guys at work, this is a marathon. You're not here to work hard 1 week. We're not here to work 60 hours a week. We're here to work 40 years. We're here to work 50 years. So gauge yourself, the amount of energy that you're spending, the amount of load that you're taking, so you can last 50 years. So you don't end up with burnouts. Yeah. That's where the work-life balance comes from, right? So you bring all these and you learn from these models and you use them. Of course, doing all this is challenging. I try to go swimming first thing in the morning when everybody is in bed. Before COVID, I did a lot of commute to work and home by cycling when of course Canada is not a 4-season country, but when the weather was nice and I was able to cycle to work, I did that. So it's or weekend rides, early morning rides. So nice. You have to find those time slots that you can fit it in. And as my kids are growing up, they are 14 and 16 right now. I have more time for these type of activities and also volunteering as well. So it's fun.
Oh, that's great. That's great. Lots to unpack there. Thank you so much. So we're going to come back in just a minute and close this one out in Pedram and our Career Factor Safety In segment. Stick around.
Before we go on here, I'd like to recognize our sponsor for this episode, PPI, a leader in engineering exam prep for the FE and PE exams. PPI provides expert prep courses and study resources designed to help you pass the FE and PE exams the first time. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. Check out PPI today at ppi2pass.com to see all the options available for FE and PE exam prep.
All right, welcome back. It's time for our Career Factor Safety In segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety in your career? Today, of course, we're speaking with Pedram MolkAra from Jacobs. Pedram, you've had a very successful career. And when you look back in your career, what's something that you've implemented in your career to give yourself a factor of safety in your career?
Well, thank you for calling it a successful career, first of all. But to answer the question, I think the question is wrong. Because like anything else that we do in geotechnical engineering, there is not only one thing for success. I cannot name one thing and I say, that made me successful.
Fair, that's fair.
And in health and safety, as you know, we need multiple items to line up for an accident to happen. It's not one mistake. It's normally few mistakes that they all line up together and the accident happens. So now let's take it back to our career. We need to have multiple levels of safety for a career to be successful.
Wow.
You mentioned about my education and studies. That's one of them. Hard work. Having the right attitude at work. Having the yes we can mentality.
Yeah.
Being respectful. Being a team player. Being able to be a leader when you need to be a leader. Being able to follow directions when you need to follow direction. It's all of them together.
It's great. That's great. Well, thank you so much. Very thoughtful response there. I like that. Thank you so much for coming on and for sharing all the great insights with us. You shared some great information and advice. I know it's going to be helpful to our listeners and those watching. Now, how can people find you? Do you have an email you want to share? We can put in the show notes, or are you on social media?
I'm on LinkedIn.
Okay.
And I do have profiles on Instagram as well. If somebody is interested to join me on LinkedIn or Instagram, I'll be happy to. And yeah.
Excellent. Well, thank you so much. This is great.
Thank you, Jared. And thank you for the time. And also this gave me an opportunity to, kind of prepare and look back, and it was a good review of going down the memory lane and looking back at the years.
That's great.
Thank you. Yeah.
Awesome. I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 76, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all of your geotechnical engineering endeavors. Peace.